Today, we are going to learn hands-on on how to test for cross-site scripting vulnerabilities when conducting DAST or web application penetration testing. And through this, we will also demonstrate reflected and stored cross-site scripting. Now, if you want a full understanding of cross-site scripting, I would recommend you watch my last two videos before moving further on this. The links are in the description of this video. Okay, let's move on. So I'm going to start with how to test for cross-site scripting vulnerabilities in a web application. So as with other types of vulnerabilities such as SQL injection and other input validation flaws, you would want to supply malicious values to the input fields in the application to test for cross-site scripting. Now the only difference here is the input in itself will be scripts in the case of cross-site scripting. Now, one very common or a straightforward script used for testing cross-site scripting is what you see in the screen. So it is an alert box with a particular number enclosed within the script tag. What this actually does is pop up an alert box if the input field is vulnerable to cross-site scripting. Now, you must also understand that the input might be vulnerable to cross-site scripting, but the application might not throw the alert box in some cases even when the script is applied. That is because for an actual script execution, there should be a HTML syntax match. And the reason I say this is because even if your script doesn't get executed, you may want to dig further to see if the input field is vulnerable. Let's see how we can do this. Say for example, there is an input field by name last name in your application profile page, and the application displays a welcome screen post login, and your HTML code for this particular logic will look like the one you see in the screen. You will have the HTML tags, and in the body section there is a paragraph, and there you see welcome to the application name followed by your last name. Now if you supply Smith as the last name, the code will now look like what you see in the screen. Now as you see here, for a proper HTML execution, all your values should be enclosed in tags. In our example, the supplied values are enclosed in a paragraph tag. Now, for some reason, if the application developer decides to enclose the supplied value in quotes, the code will now look like the same code, but the last name enclosed within quotes. Now, if you supply a normal script like the one we discussed few seconds ago, execution will not happen due to a syntactical error, since the code now will look like what you see in the screen, where you have welcome to application name and your script enclosed within quotes, which means it will not get executed. In such a case, you can still break the logic by using a different variant of the same script to match the syntax. So what I'm going to do here is I'm going to add a ending quotes and then supply a paragraph tag and enclose the script and alert within the paragraph tag. And I'm going to end my input with a HTML comment. Now, this is a comment tag in HTML, and anything after it will be ignored. Now your code will look like what you see in the screen, where the last name is more like a empty string, or there is not a last name at all, but the script that we actually supplied is already there, and this will now execute because there is no syntax error. So in real time exploits, or when you perform testing, it is not required for you to analyze to this extent to see if an input field is vulnerable. Rather, you can use a cheat sheet. One such cheat sheet for cross-site scripting is provided by OWASP. I've given a link to it in the description of this video. All you can do is pick and run the scripts one after the other in your input field to see if the script will execute. Okay, now I wanted to give you all a basic understanding of how scripts work before we get into a demo. With that, let's dive into a demo now. So I'm going to start with reflected cross-site scripting, and I'm going to try and exploit the same in Altro Mutual website. So I log in and I supply a script in the search bar at the top. And there you go. You see an alert. Okay. If you remember in the previous sessions, we studied that for cross-site scripting to happen, the supplied scripts should come back to the application front end. Let me explain this with this demo. So here we are supplying the input in the search bar and we see the script executed. How did it really come back? So I'm going to verify by looking at the source of this page, which is the HTML code, and I'm going to search for the supplied script. There you go. We have the entire script that we supplied and there is a syntax match. Now also remember, reflected cross-site scripting is not persistent. So the scripts you supply execute only once in the current session that you have logged in, and it does not affect any other user of this particular application. Let's move on to stored cross-site scripting now. So in the case of stored cross-site scripting, which is persistent cross-site scripting, the script that we supply will be stored either in the web server or the database and will be executed every time we access a page. Now this can also affect other users in the application. Let's see how. So for stored cross-site scripting, again, the testing methodology is the same. The only difference is the script is being stored in the database or the web server. So I want to try stored cross-site scripting in a sample application, the one you see in the screen. The application is more like a blog where you can read and also comment your thoughts for all users to see. Now I'm going to go to a particular blog and add a script as a comment. There you have it. The comment is made and I go back to the blog to see it executed. And every time you refresh the page, it gets executed. To make it worse, this is a common block accessed by all users, and so the script we supplied will be executed on all user screens when they access this page. Now, you must also understand cross-site scripting is not just about execution of scripts for you to see alert boxes popping up in the screen. The examples we have used here are only for testing purposes to confirm the existence of cross-site scripting. In an actual exploit, you would rather want to extract sensitive information such as session IDs and cookies. How do you do that? So instead of executing alerts, you can retrieve cookies using document.cookie. So let's execute script alert of document.cookie, and there you see the cookie value displayed. We will learn more about cross-site scripting testing tools for DAST and penetration testing, and also conduct a real-time exploit in the upcoming sessions. Keep watching, like, share and subscribe if these sessions are helpful to you.